It's my great pleasure to welcome next here on the AC/DC Build Stuff virtual stage. Theme this year is Rocking Your Code. And next up on the AC/DC stage, please welcome somebody who has been developing software professionally for well over 20 years. They run the Norwegian .NET user group out of Oslo. They're a Microsoft MVP on the AI program. They're going to be talking us today about bringing humans and machines closer through emotions. Please give a big Build Stuff welcome to Håkan Silfvernagel.
Yeah, thank you so much for everyone that is joining this talk. Now, I would like to ask you to consider a situation that you bought a new technical gadget and you set it up and it doesn't really work. And then you know what you do? You commit a real crime. You actually look into the manual. But unfortunately, that doesn't really help either. So what is next thing? Okay, you try to get to support to see maybe someone from support can help me. But what happens is they don't have a telephone number. You just have to deal with a chatbot. So you're talking to the chatbot and asking him, describing your situation, but nothing really happens. And you get more and more frustrated. And then you say that, oh, I just want to throw my PC out of the window because my PC doesn't really understand me. Have you ever had such a situation before? Well, I have, and that's not such a pleasant experience. But maybe it's time for us as developers to do something about it. So that is what my talk is going to be about tonight here. So I'm going to talk about affective computing. So how can we bring humans and machines closer through emotions? So, but before we start, I'm just going to give you some background information about me. So my background is in human-machine interfaces for process automation and robotics. And my educational background is a master's degree in electrical engineering, and I also have a master's degree in behavior science. I'm interested in artificial intelligence and Internet of Things, so I've taken a couple of classes in that. And as Dylan said, I am a Microsoft MVP in AI, and I'm also part of the Oslo AI meetup in Oslo, and also the Norwegian.net user group. But that's enough about me here. So what is affective computing? Well, a short explanation is that affective computing is the human side of artificial intelligence. But if you want to have a little bit longer explanation, we can say that this is the study and development of systems and devices that can recognize, interpret, process, and simulate human effects. And that is what we call emotions. So basically this, how can we use emotions in order to have a better interaction with machines, but also better interaction with ourselves from humans to humans. So before we talk more about this, it's important for us to get some basic understanding into some terminology. So first thing that we're going to talk about is what is actually an emotion. So when we talk about emotions, we actually mean three different things here. So one of them is from what we from psychology call emotions, which is a fast automatic response to something. And this is something which is temporary, and it's a react to stressors. And emotions, they are common to all people. And then the second concept here is called feelings. So with feelings, we need to involve our cognitive parts of the brain, our cognitive awareness. So that means that we need to be aware of the environment and of our emotions. And this also includes a thought process, and this is much more long-lasting. And then finally, we have mood and effect. So this is if you mix feelings and emotions together. And the effect is something more complex, and it could also be long-lasting. So for us to understand emotions a little bit better, I'm going to describe 4 well-known theories of emotions. So I'm going to start with the James Lang theory of emotion, then we go through Cannon Bird, Jacques de Singer, and then finally Lazarus. So the first theory of emotion is from James Lang. This is a theory from 1880. So what they said is that when we see something external stimuli, it will lead to a physiological reaction. And our emotional reaction is dependent on how we interpret this physiological reaction. So for a concrete example here is if you're out walking in the wood and then you see a grizzly bear, then you will have a physiological reaction. Your body will start to tremble and your heartbeat will start to race. And according to this James Lang, they say that we will interpret this physiological response, and then we will conclude that we're frightened. So that means that you're not trembling because you're frightened. You feel frightened because you're trembling. But obviously this has some downsides to it, because that means that in order for us to feel an emotion, we need to be able to experience it physically, and that's not the case here. A little bit later on, there was a challenge to this theory by two researchers called Cannon and Bird. They said that we feel emotions and our physiological response simultaneously. And then in the brain, there is a part called the thalamus. It will send a signal to the brain, which results in a physiological reaction. So if you see a snake, for example, then you're afraid and you begin to tremble. So people will experience the same physiological response to different emotions. So for example, sweating and heartbeat and respirations, they are all common both for fear, excitement, and anger. And in this model, emotion and the physiological response are independent of each other. And if we fast forward here to the 1960s, there is something which is called the two-factor theory of emotions, or the cognitive theory of emotion. And in this theory, they focus on the interaction between two different factors. It's the physiological response and also the cognitive labeling of that response. So here an example is you're alone in the parking lot, and then you see a strange man is appearing, and he walks towards you fast. So what will happen is the following. First, you see a strange man appearing, then your heartbeat will start to race and you tremble, and then this rapid heart rate and trembling are caused by fear. And this is a cognitive labeling, and then you conclude that you're frightened. And then one of the more recent theory of emotion is from Lazarus, and this is from the 1980s. So what they said is we will do first a cognitive appraisal. So a cognitive appraisal is to say, what does this mean? And it could be, for example, this is not important, or this is good, or this is very stressful. So first you do a primary cognitive appraisal, and then after that you do secondary appraisal. So for example, if it's a positive appraisal, you can say, I can do this if I do my best, or if this fails, I will just try another method. But you can also have a negative appraisal. Then you say that, oh, I can't do this. I know I will fail. I won't even try because my chances are too low. So an example is if you see a bear in the woods, then your primary appraisal is this is very stressful. And then your secondary appraisal could be that I can actually escape. So here the emotional experience of fear and the physiological response. So now when we know a little bit more about what emotions is, then we can talk about how can we measure emotions. So to understand this, we need to go back to the late 1800s. Then Charles Darwin, he wrote a book called The Expression of the Emotions in Man and Animals. And in this book, he claimed that emotions, they are universal across the human species. And he also said that emotions have an evolutionary history. And around the same time, in the 1860, there was a French physician called Duchenne. He wanted to make a book where he could depict different facial expressions, and he wanted to be able to map these facial expressions to specific emotions. So what he did was that he used an electrical probe, and then he induced a small current into the facial muscles of his patients. And then he documented this by taking a photograph. And he said that he could identify 60 discrete emotions by manipulating the facial expressions in the patients. And if we go forward another 100 years, then there's an American psychologist called Paul Ekman. He did studies regarding facial expressions and emotions. So he traveled to Papua New Guinea to study facial expressions. And what he did was he selected an isolated tribe, and then he found evidence that facial expressions and emotions are actually universal. What he also did was he developed something we call an atlas of the human facial expressions, or the facial action coding systems. And this is a system that is still used today when we do user studies or behavioral studies of persons and emotions. can we do if we want to detect the emotions? So there are three means for emotion detection. The first one is to study the facial and the bodily expressions. So in this slide here, you can see what we call universal emotions. So it differs a little bit. Sometimes they say that it's 7 universal emotions and sometimes 9, but these are some of the more common universal emotions. Then, in addition to study facial and bodily expressions, you can also study speech. So what you do is you study the tone of the speaker, you can study the intonation, the posation, and the rhythm, and that will reveal what kind of emotions he or she is experiencing. And then the third way that we can detect emotions is through physiological-based measures. So this is if you measure the EEG or the heart rate, or, for example, the skin conductance. So now when we have some background in both what emotions are and also how we can measure emotions, we can go into affective computing. So affective computing is started in the middle of the 1990s. There was a researcher at the MIT Media Lab called Rosalind Picard, and she published a book that she titled Affective Computing. And by doing so, she started a whole new field of research. And by now, it has its own IEEE proceedings, as well as international conferences and multiple research groups in various parts of the world. What she wrote in her book was that we should be able to use machines in order to detect emotions. So a machine should be able to sense the emotional state of its user, and it should do so by using sensors, cameras, and microphones. And we should be able to use speech recognition, gesture recognition, and image recognition. And the basis for all of this should be machine learning. And we have to take into account that this was in the 1990s, so a lot of the state of the compute and also the state of machine learning was too low. So a lot of this was a little bit science fiction at the time. But as we know now, machine learning and AI is very, very popular technologies. So one of the reasons that they are so popular now today is the number of enabling technologies. So one of the enabling technologies is the fact that we have access to smart sensors that can enable real-time data flow. And we have also access to big data solutions, so we can handle large amounts of data, both storage and transforming and processing data. And we have machine learning algorithms that are scalable that we can use to make sense of the data. And luckily for us as developers, a lot of the cloud providers are exposing these as services that we can make use of in our own applications. So now I'm actually going to show you first here. So here is one example here from the Cognitive Services suite from Microsoft. So this is called the Emotion API. So what we can do here is we can analyze and picture, and then we can get back an emotion profile, as you can see here, for example. So Microsoft is not alone. So Amazon has also something called the Amazon Recognition, and IBM has also similar types of services. What I would like to do now is I'm going to show you a simple example here of the face detection API, how we can use that. So I'm going to switch over to the browser here. So what you want to do, so this is the Azure portal. So you want to go and you want to create a new resource. And then you just need to search for a face. And then you can create a face resource here. So you just have to choose your subscription. You have to select the resource group and which region, and you need to name the resource and also what pricing tier you want to have. So I've done all that beforehand. And then what you can do later on is if you want to try that out, then you can use special service here where we can scroll down a little bit here. We just name the resource that we just have set up. So I have to call it face detection silver, and then we can add some parameters here. So one of the important parameters for the face detection is we want to get back the emotion face attributes. So if we specify that we want to have that back, we will get these emotion attributes that we saw in the slide before here. And then after that, we need to add our subscription key, and then we can just make a call here. So I have a picture which looks like this. One moment. Yeah, so this is the picture that we're going to use, and then we can do a request like this, and then we can see here, then we will get both a rectangle for where the face actually is, and then we also get the emotional attributes here of the face, and we can see here that this face detection API will say that it's 83% probability that this boy is experiencing surprise. So let me switch back here to the slide. So another thing that we can do is sentiment analysis. So sentiment analysis can, for example, be used if you have a lot of reviews and you want to get, a general impression of how satisfied your customers are with your business. Then you can collect all the reviews, and then you can do a sentiment analysis to see what is the emotional content of these reviews. So I'm going to show you how you can do this. So let me switch over again here to the Azure portal. So we want to start for a new sentiment analysis. So then you create a new instance of the sentiment analysis, and then you just you choose the subscription and so on, and then you can set it up. So I've done also this beforehand. So we can go again to this test console. So this is the test console for text analytics APIs. So then we name our resource, and we also need to provide our subscription key, and then we can add a document here, which is just JSON object with some documents. So here there is a text here. So if I zoom out this a little bit, so you can see here there's a review. It's a great atmosphere, close and plenty of restaurants, hotel and transit staff are friendly and helpful. And then there's a second review here, bad atmosphere, not close to the center, staff are not friendly and helpful. So if we send this in to the sentiment analysis API, we will get back here that the first sentiment is positive. So we can see that we also get the confidence score that it has 1.0 for positive, and then 0 for the other, for neutral or negative. And you get that for all the sentences in the document. And then you also get a sentence for the second review that overall it's negative, and then you get how it came to that conclusion. So let me switch back here. So these are some examples with services that we can use out of the box. I'm going to describe a couple of application scenarios where this has been used. So, the first scenario here is within retail. So in retail, you can imagine that you have a store equipped with cameras. So the cameras can register the facial expressions of customers, and then they can determine the emotions of the customers. So by doing so, the staff can use this information to enhance both the service, and they will also be able to give a much better experience to the customers. And we can think of the medical field. In the medical field, you could use these physiological-based measures to determine the patient's emotional state, and by doing so, you could reduce the stress, among other things, for the patients. And also the medical team could be able to respond quicker to the needs of the patient. And we can think of in the educational sector. So here the teacher could use cameras to detect the emotions through facial expressions of the students. And if he sees that the majority of the students are feeling bored, then the teacher could change his method of teaching. And this could also be used in an online setting where we could make use of the web cameras in order to measure the emotions of the remote students. And then finally, we also have an application scenarios from the social field. So one problem here in the large parts of the Western world is that we have a growing population of elderly people, but we don't have enough of workers that can help them and aid them in their daily life. So in Japan, they have done experiments using robots. So the robots can socialize with the elderly using both facial recognition, speech and tone evaluation, and physiological measures to adjust the robot's behavior towards these elderly people. So now I would like to talk a little bit about what is in the front line of affective computing. So there's a company called Affectiva, which also stems from the MIT Media Lab. And Affectiva, they say that they have the world's largest emotion database. They have 6 million faces across 87 different countries. And what they do is they offer this as an emotion SDK and an API so that we as developers, we can integrate their technology into our own products. So some example of use cases are virtual assistant, where they can recognize the emotion of the user. And you can also think about a personalized transportation experience. If you have a self-driving car, for example, it can detect the emotional state of the passengers, and if he sees that they're in a good mood, he can adjust the route, the music, and other things. So maybe he takes the scenic route, but maybe if he detects that they're in a bad mood, he will just take the shortest path between two different points. And another example of use cases in the advertisement industry. So in the advertisement industry, it's important to elicit the right emotion at the right time. So what you can do is you can use this in order to understand if an ad will create the right emotion, and also at what time during the ad this emotion will be experienced. So they have also used this technology in order to do facial analysis and also do facial and head tracking, for example, in indoor car systems, so that you can detect if a driver is turning drowsy and maybe gets very sleepy. Then this system can alert the driver so that he doesn't have a car accident. I would also like to talk a little bit about Pepper. So Pepper is a robot developed by SoftBank Robotics, which is a Japanese company which is focusing on making robots that can adapt to humans. So Pepper was introduced in 2015, and he can determine the emotions of the people around him, both by utilizing voice and facial recognition, as well as body movements. And he is responding by changing both the color of his eyes and the tone of his voice and the content which is displayed on the tablet. And Pepper has been used in large banks in Japan, in Nestlé and Nescafé stores, and also in the railway stations in various places in Japan. And also a fun fact here that as of August 2018, Pepper is using the Affectiva API that we were just talking about for emotion recognition. Now I would like to talk a little bit more about AI and what is called artificial general intelligence. So artificial general intelligence, or AGI, is when a machine can perform any type of intellectual task that a human can. And the opposite thing to that is what we call narrow intelligence. So narrow intelligence is what we basically have now, where the AI can only solve a specific problem solving or a specific reasoning task. So this general intelligence is also when we can use something called cross-domain optimization. So that means that we can achieve complex goals in complex environments, and we should also be able to transfer learning from one domain to a completely other domain. And we have also some competitions or some that tries to define this AGI. When can we say that we have reached this? And one of these tests is called the Turing Test. So the Turing Test was first described in the 1950s by Alan Turing, and it has many different types of interpretation. But in this case, we want to talk about something which is called the Loebner prize competition. And this Loebner prize competition has been in use since the 1990s. And they say that the program will win $1 million here if it can fool half the judges into thinking that it's a human while it's interacting with them in a free-form conversation for 30 minutes and also interpreting audio-visual input. Another test that we have here for AGI is what we call the coffee test. And here the AI should be able to go into an average American house and figure out how to make coffee. And this also involves including identify what is the coffee machine and figure out what does the different buttons do, and finding the coffee in the cabinet and so on. We also have something called the robot college test, and that is when a robot can enroll in a human university and take classes in the same way as us humans do, and also get a degree. And then we can say that we've created an artificial general intelligence. And then finally, we have the employment test, and this is when machines can show true human level intelligence so that they can do many of the things that us humans are able to do. So one question that we can ask ourselves is this future, is this a threat or a hope? And I'm just going to take something to drink here. So let's have a look at what some famous people have said. So Elon Musk, he said that with artificial intelligence, we're summoning the demon. AI is our biggest existential threat. And then we have Stephen Hawking. He said that the development of full artificial intelligence could actually spell the end of the human race. It would take off on its own and redesign itself at an ever-increasing rate. Humans who are limited by slow biological evolution couldn't compete and would be superseded. And then we have one of the fathers of AI here, Marvin Minsky. He said that once the computers get control, we might never get it back. We should survive at their sufferance, and if we're lucky, they might keep us as pets. And that doesn't sound like, a very bright future here. But then it could also be interesting to look back at what have people said in the past. So, for example, here there were two researchers here in the 1970s. They said that a specific type of machine learning called symbol systems modeling, human problem solving, is the answer, and we better alert the people. But they didn't really have to alert the people because it hasn't meant that much to us. And also in 1982, there was something called rule-based systems. So there were some researchers that wrote a book where they claimed that Japan will dominate the world because they will use these rule-based systems. But that didn't really happen either. The question here, when will this happen? When will we reach the state that artificial intelligence will surpass human level intelligence? And if this happens, will it be a good thing or a bad thing? So there's a researcher at MIT called Max Tegmark. He has done a survey among the leading research community within AI and machine learning, where he's asked these questions. And then he has collected it, and he said that you can find different types of groups. So first of all, if you ask the research community, will this happen in a few years? There's virtually no one that thinks this. But if you ask them, will it happen in a few decades, up to 100 years, then there are some people that think this, and then you can divide this group into 3 different subgroups. Either there are the Luddites, they think that if this happens, it will definitely be a bad thing. And then you have the digital utopians. They say that if this happens, it will definitely be a good thing. And then you have what we can call the beneficial AI movements. So they are somewhere in between. And then you also have the technoskeptics. They think that this will not happen in 100 years and maybe not even within 300 years. And it might be that it will never happen. So we can see that even the research community, their opinions are pretty widespread in this idea. So one of the things that are also important to think about is about ethical AI. So in ethical AI, there is a standard problem, which is called the moral machine. And this type of the moral machine, or this experiment, was launched in 2014. And there are millions of people in several hundred countries that has been through this test. And what this test says is that you have a hypothetical situation here, that you have a self-driving car which approaches a zebra crossing, and then there are people on this zebra crossing. So the question is, what should this self-driving car do? So then you get to choose here, either should it, for example, prioritize humans over pets, or should it try to save the passengers in the car over pedestrians? Should it try to save more lives over fewer lives, women over men, young over old, fit over sick, and so on? And it could also be a question here, should the car actually take any action or not? So what they found was that these kind of moral questions vary a lot on the basis both of culture, of the economical status, and of the geographic location. So we're going to have a quick look here at a couple of results here. So what they found was that countries with a more individualistic culture, such as United Kingdom and United States, they are much more likely to spare the young people than countries, for example, Japan and China. And they also found that countries with more individualistic culture are more likely to spare more lives. This is also from United Kingdom and United States, and as opposed to China and Japan. And they asked how they can compare in sparing pedestrians over passengers. And you can see that more group-oriented countries like Japan, they will do that instead of other countries like China. So now when we've seen this, then it's important for us to realize that how can we assume that a machine learning algorithm should be able to have an objective moral thought when we as humans can't really agree on what is the moral right thing to do? And this has also implications for us as developers, because quite obviously the moral implications when we develop these machine learning algorithms will actually vary based on the culture where this machine learning algorithm has been developed, and what kind of culture the developers are coming from. So this is an important thing to take into consideration. And now to summarize here my talk here, I just want to touch upon something called collective intelligence. So collective intelligence is nothing new here. It's been known for a long time that a group of people will have a much higher chance of achieving great results than a set of individuals. So some researchers, they wanted to find out what is a distinguishing character of these groups. So first they thought that maybe it's based on the individual IQ of the people in the groups, but they can only find a moderate correlation with that. Instead, they found 3 other factors. So the first factor is something which is called the average social perceptiveness. And this is a test that you can do online. So what will happen is you will be given a set of images where you can only see the eye portion of a face, and then you should be able to read the emotions just by observing the eyes. And then the second factor is participation in group conversation. So here they found that it's important that you don't have a dominant person in the group, and it's important that everyone should be able to have their say. And the third factor is the proportion of women in the group. So they found that more women, more intelligent groups. And this has to do with the first factor that I was talking about, this social perceptiveness. So what this means for us is that for us as individuals, we need to be good at working together. We have to have great interpersonal skills. And for computers and for machine learning algorithms, we need to design these so that they can work well with people. And this is what we can use affective computing for. I hope that this presentation got you inspired to learn more about this. So I have some references for you if you want to study it more in detail here. So the first book is the book that was written by Rosalind Picard in the 1990s called Affective Computing. And then we have a book called The Blueprint for Affective Computing by Klaus Scherer and Tanja Bensinger. And then we have the Oxford Handbook of Effective Computing by Calvo de Mello, Gratch, and Kappas. That I would like to thank all of you for tuning in to my talk. And if you have any questions or any comments, you can reach me on Twitter, or you can send me an email, or you can probably come to a chat session here, which will take place right after this. So that I just want to wish you a great conference ahead. Thank you so much.
Thank you, Håkan, and thank you, everyone. So we just have a couple of questions on the stream here. So there's a question: what is your opinion on the ethical implications of application use cases? Do you believe that emotions should be monetized? Are emotions protected by privacy data laws? Nice, easy question there. What do you think?
As you say here, this is a very complex topic. So so me, as living in the Western world, we are thinking a lot about the privacy, both the privacy of data, and you can say that probably our emotions should also be maybe even more highly valued than the data that we actually keep. So there should probably be some legislation that takes this into account. But as we also know, there are other countries where the personal privacy is not so highly valued, and where they will actually make use of every type of data that they can get hold of. And so they could probably make use of these emotional APIs that we have been talking about, both for good and for bad. So what I think is important here is that people realize that these type of technologies exist, and that we probably need to have a public debate about it. What should be allowed and what should not be allowed.
Good answer. So Justina says it's almost the same question. How can such technology be sold as a solution for companies and things when there's no regulation yet? I think you pretty much covered that one there.
I can also say a couple of more things here. So so one of the things that was quite recent here was that a lot of companies, they actually said that they would prohibit some of these uses of these technologies, actually, because they found out that there are too much danger right now, that we need some more privacy legislation in order for everyone to be able to use it. And also on a national basis here in Norway, there is talk about having a governmental instance which should be able to evaluate ethical use of AI. So that you probably, when you make an application, maybe you need to get it approved by this ethical AI instance. So I guess that's some of the ways that I can see that these things can take going forward.
Stuff. And then the last question we've got in the chat here is looking at the trolley problem as an instance. What is your opinion on it? Should there be a centralized system of AI judges, or a centralized system of AI that judges who to sacrifice and who to save in a car accident, or every country should have their own system depending on the? It says on the pools here.
I guess then you have to be aware here of which country you are when you're going to have your accident, I suppose.
Well, I mean, it's interesting. Yeah, sorry, go on.
Yeah, so I guess I don't really have any good question to that. But one thing that I just mentioned here, which is also an interesting idea, that should actually, if the car detects that it's in this type of situation, the zebra crossing situation, maybe it should release the power over to the human. That could be one thing, that they say that maybe the producer says that we can't really take any responsibility for this, so we'll just ring an alarm or something, and then all of a sudden you're in the manual mode.
I mean, that's interesting, because you then get a situation where you're in your car, you're on autopilot, maybe kind of half asleep, and suddenly it's like you have 0.3 seconds to decide whether to kill a puppy or a nun.
Yes.
And somebody's going to die, but the machine won't be at fault because it woke the human up. So no, it's fascinating. It really is.
And it's also fascinating talking about the legal implications here. So is it the car manufacturer, or is it the company that made the machine learning algorithm, or who is really here to take the responsibility?
Yeah, no, it's And one of the interesting things I see there is every time you see that there's been an out-of-court settlement, what it means somebody's paid a lot of money to avoid a judge getting involved and making a law. Because if the stuff ever actually went to court, then judges and courts would say, yes, the vehicle manufacturer is liable. And that's not happened yet. You know, all these settlements, they're just kind of pushing that question further and further down the road. But that was brilliant. Really, really interesting presentation. Thank you so much for presenting. Thank you, everybody, for joining us. Wow, you got 198 people on the stream right now. Build Stuff is big this year. We got nearly 1,000 people tuned in across all the different tracks. So yeah, thank you, everyone, for tuning in. Thank you, Håkan, for being part of it all and speaking to us today.